With this lesson, all we really want to do is just focus on learning more of those properties of logs and exponents and just really connecting the exponential function and the logarithmic function more in tune with each other. So right now, what properties we've kind of learned is the fact of, let's say, if we had, let's say, log base 2 of 8 equals 3, then if we wanted to, we could take it out of that form and write it as 2 cubed equals 8. Okay? And so that's one of the first properties, but we learned some more properties, and y'all kind of saw the whole long list of them right up here in this lesson. So we're going to take that and kind of start with some problems. So the first thing we want to do is expand log base 4 of x squared y cubed. What expand means is just write it into a several logs. Instead of just writing it as a single log, we want to write it as several logs. So if we go into this parentheses right here, we actually have two things. We have a product of x squared and then y cubed. So since there's two things or a product of two terms in here, that's how many logs I'm going to create. And every time I create a log, it's always going to be the same type. The type being the 4 base, okay? So I have log base 4 of one thing and log base 4 of another. I'm creating two different logs, but keeping that same type. The first thing it's going to be is log base 4 of x squared. The next thing is y cubed. And then the property says that log of a product, when you separate it with a plus sign. Okay, and the reason where this comes in is if we go back to our exponential properties, if I told you to take x squared and multiply it by x cubed, what do you do to your exponents right here? Well, we add them. So in other words, bases that are multiplied, you add your exponents. Here, logs that are multiplied, you add them up, and that's where that's all coming from. Okay? And last but not least, there's this property that says is if what you're taking the log of has an exponent, we could leave that there or we can move that exponent. And where we could move it to is actually the front. So 2 log base 4 of x plus 3 log base 4 of y. And that is a way that we can expand that single log into two logs. Okay. Going to our next example, we're going to expand another log, and this time we have a fraction. And if I kind of want to go back over into my exponential rules, if I had x to the 4th over x squared, and I wanted to clean that up, if I have two common bases being divided, remember I subtract my exponents, so 4 minus 2. Okay, well I've got a situation here where I'm dividing a log, so guess what? It's going to involve some subtraction here. Alright. The type of log where there's not a base written, whenever the base is not written, it's always understood to be base 10. So I could either choose to write log base 10, or if I don't want to, I don't have to. It's always understood that whenever a base is not written for log, it always is 10. Mainly that's because that's what our calculators are programmed into. It's kind of that common that all the scientists and everything use, okay? So we want to break it up. We've got several things going on here. We've got our numerator. The only thing in the numerator is 1, so we have log of 1. And then I'm going to subtract. And here's the shortcut. Is because all the rest of this, the x's, the y's, and the z's are all in the denominator, I'm always going to make sure that I lead this with the minus sign. So the first thing we have is an x squared. So I'm going to go minus log of x squared. The next thing in that product is a y cubed, and since the y cubed is in the denominator, I'm going to lead with a minus log of y cubed. And the z to the 4th is also in the denominator, so I'm going to lead with a minus log of z to the 4th. So it's almost like if you've got several terms in the numerator, make sure you lead through the expansions with plus signs. If you've got several terms in the denominator, lead through the expansion with minus signs, and it kind of takes care of two things with one stone. Okay? Well, what is the log of 1? The log of 1 actually is always 0, no matter what your base is. So this is really 0 minus, I'm going to bring the exponents down front, so minus 2 log of x minus 3 log of y and minus 4 log of z. And we are all done with that example. And just for kicks, let's say if that problem actually said, let's take the log of, gosh, what I see, let's say maybe 2x over x squared y cubed z to the 4th, and I wanted to expand this, what I would write it out So as would be, okay, everything in the top, there's a product technically of two things. So it would be the log of 2 plus the log of x. Okay, the 2 and the x were both in the numerator, so these terms are both positive. Now everything else is the denominator, so then it would be minus, log of x squared minus log of y cubed and minus the log of z to the fourth, and then bring all those exponents down. So that'd be kind of what to look for in case that top had something other than just a 1. Okay? And one last thing before we actually go to the next problem, I want to give you a little side note. If I told you to expand the log of x plus y, there's nothing you could do. It doesn't go anywhere else because you can only expand when what's inside of here is either a product or in a quotient or a fraction. In other words, if you've got things being divided or multiplied, that's it. If you have adding, subtracting, you can't do anything else. So log of x plus y is just going to stay the log of x plus y. All right, let's go into example 3. We know that log base b of 2 is going to equal m, and log base b of 3 is going to equal n. So what we want to do is take log base b of the cube root of 24 and figure out what does that equal. Is it equal like m times n? Does it equal m cubed times n? We want to kind of figure that out. Okay? Well, let's kind of figure out, let's do some properties. So log base b of the cube root of 24. Well, the first thing I can think of is the fact that I can write the cube root as 24 to, I don't know, let's say the 1/3 power. Okay? From there, I need to write 24 as really products of 2 and 3, because that's what we know. So let's think here. 24, we can write that as log base b of, let's see, 1/3. So let's see, 8 times 3 would be 24. So we can write that as 8 times 3 to the 1/3. So instead of 24 to the 1/3, it's going to be 8 times 3. And then keeping this up just a little bit more, so it's just in the terms of 2 and 3, 8 is 2 cubed times 3, all to the 1/3 power. Okay, so what I did was I wrote 24 instead of the cube root would be the 1/3 power, and then I wrote 24 as a product of hopefully getting to just 2s and 3s. Okay, all right, let's finish cleaning this up just some more. Let's expand this log out. Okay, because I'm taking the log of a product and I can split it up. If I want to, maybe let's move the 1/3 down front. So it'll be 1/3 the log of 2 cubed times 3. So when I expand it out, I'm going to be multiplying 1/3 times the log of 2 cubed plus 1/3 times the log of 3. Okay, this 1/3 log 3, that's done. There's no exponent up here, so we can stop right there for just a second. Right here on the front one, though, let's bring that 3 down front and multiply it in. Well, 3 times 1/3 is actually just 1. So it's going to be log of 2 plus 1/3 log of 3. And if we go all the way back up into our original directions, it says I can take all log base 2. Anywhere I see log base 2, I can replace it with m. Well, here I see log of 2. I guess I dropped my b's along here, didn't I? Let me put those in real quick. Okay, so log base b of 2, all of that right there is m. All of log base b of 3 is n. Well, here's log base b of 3, and all I have to do is, since it's being multiplied by 1/3, I'm going to multiply log base b of 3, which is n, times 1/3. Kind of wrote that 1/3 a little sloppy. Let's clean that up just real quick so y'all can get it nice and pretty in your notes. All right. So going back to the original problem, yes, this was long. I know. If you have to rewind it to watch this again, totally go for it. I just try to pick a harder problem so y'all can get really good practice with it. But log base b of the cube root of 24, all written out in terms of m's and n's, is really going to be m plus 1/3 n. Okay, and the key is whatever you're trying to rewrite, here it was the cube root of 24, you're just trying to get it into powers or terms of just 2s and 3s, and that was the goal. Okay, so let's go on to the next example.